welcome to session 3 of module 15, Cybersecurity Objectives, Strategy and Requirements. In this session, we will be looking at cybersecurity objectives, its requirement, strategy, and how do we do the risk assessment and evaluation of the requirements. So like any other cybersecurity, even for smart grid cybersecurity, the objectives remains the same. The objectives are data availability, data confidentiality, and data integrity. So what we call as data availability, it refers to the timely and reliable access to the use of information, asset, or any device. Data confidentiality, it refers to the protecting personal privacy and proprietary information from unauthorized access. It could be the information about asset, or it could be the information about organization or an end customer. Data integrity, it refers to preventing and detecting the modification of information by unauthorized persons or system. So let's look at availability in the case as a smart grid objective. So availability is the most important security objective for power system reliability. The time latency associated with availability can vary from few milliseconds to even months. So the criticality varies. If data is not available within a millisecond, there could be some issue which can come, or some of the cases if the data is not available after a month, or the issues can come. So the availability is the important security objective. So for the first point, what we see is less than 4 milliseconds of time is given for protective relaying. So any data which is being coming from the relay has to come within less than 4 milliseconds. That is the requirement. If the data comes after that, that is of no use. Subsequence for transmission wide area situational awareness monitoring, and a few seconds for substation and SCADA feeder data. So if the availability of data is changed, then that decision making can create problem. A few minutes for monitoring non-critical equipment and some market pricing information, and hours of meter reading and long-term market pricing information, and for few days and few weeks or few months for collecting long-term data such as power quality information. So what we see here is timely availability of data or asset is very important, and that is the first main objective of smart grid cybersecurity. So if any disruption of access to or use of information can have limited, high, or very high impact. Based on that, it is classified into low, high, low, medium, and high risk. So when we are talking about availability, there is a classification which is also given to that. Next one is the integrity. Integrity for power system operations include assurance that data has not been modified without authorization. Source of data is authenticated. It's not given, or it is not a spurious data, or it is not a intruders data, or data which is been injected. And NISTR 7628 has given guidelines for data integrity. The timestamp associated with the data has to be known and authenticated. So if a data comes to us and if it has a timestamp which is of a future, then that is not the correct data. So the data which is coming has to be correctly matched with a timestamp. And also the quality of the data has to be known and authenticated. These are the following points which has to be taken care and which has to be met as part of the integrity. So if unauthorized modifications or destruction of information could be expected to have limited, high, or very adverse effects on organizational operations. It could be on the assets or at the individuals. Based on this, here again it is classified into low risk, medium risk, and very high risk. In confidentiality, so the last objective of the smart grid cybersecurity is confidentiality. Confidentiality is not of very high priority, but it is very important. And confidentiality is the least critical for power system reliability. However, confidentiality is becoming more important, particularly with the increasing availability of customers' information online. So if the data of a customer is known, then a lot of input about the customer will be available and in a open form. Privacy of customer information, electric market information, and general corporate information such as payroll, internal strategic planning. So all these things has to be taken care. So confidentiality also is very important, and that is the last objective for cyber security in smart grid. The unauthorized disclosure of information uh, to have, it might have limited, again, high or very high impact. Example, if a person whose name this much power is consumed, if it is known, then it may not be of high impact. But if industry is consuming so much power and they are spending so much money on this kind of information is available to a public, then it might impact. So the confidentiality can vary from low, high, or medium risks. And the requirements, if you look at the diagram, we have cyber security. The first three are the objective, and the last 6 points are the requirements which is derived from this objective to meet these objectives. Identification of a person, authentication, authorization, and trust. When the data is coming, it has to be the authenticated data, that is the trust. And access control, limited access control, and only for people who can use the machine or use the data or use the system. And also privacy. These are the different requirements which is derived out from the objectives. So there are many cybersecurity systems which are existing, or IT networks which are existing now, which almost meet all the required for the cybersecurity. This IT security system become a shortcome when it comes to control and automation level. At the above level, they all meet all the requirements. Power automation systems and applications were not originally designed for general IT environment. So it was designed assuming it is an isolated environment and data is not shared in a network. Smart grid cybersecurity requirements, if you are looking at, NIST has given some set of requirements how each and every requirement has to be derived. So first thing is determine the logical interface categories. We will be looking at different logical interface category in the next session. A thorough analysis of actor, what all the different actors, what are the different domains and information systems and network, and what is a communication requirement to adequately determine the logical interface. So these are the various points which has to be added as part of the requirement. Then assess the risk, identify the threats, security constraints, and issue associated with each logical interface category. There are 22 different logical interface category which is given by NIST, which we'll be covering later. So, we need to identify that, and risks at different interface has to be identified. Select the initial set of baseline security requirement based on the logical interface category. And first you identify the logical interface and determine the basic level of requirement. Then based on the company, industry, domain, you can tailor made and fine tune the requirement to meet the industry or to meet the different stages of the domain. So, as part of cyber security strategy, NISTR 720 has given guidelines. So these are the guidelines which overall they have at a high level they have specified. It is a necessity of the system which is implementing the cyber security to take these guidelines, but follow or fine tune and add more inputs to it to have a final strategy for that organization. Standard regulatory policy, the competent body should have develop policy and regulatory framework that provide supporting environment for cybersecurity objectives. Develop risk assessment methodologies that assess threats, vulnerabilities, and what kind of impact it gives. Privacy is of paramount importance, and measures should be taken to protect four key aspects of user privacy. The first one being personal information, second one is personal privacy, third is behavioral privacy, and fourth is personal communication privacy. And develop security architecture that is linked on smart grid conceptual reference model. So that model we will be looking at in the next session. And the next one is the certification. So when we are talking about this strategy and we are talking about security at different level, we need to have certification process to identify whether this security can be met, and we have to provide assessment at various level to in order to have the or objective met. Develop certification schemes for smart grid devices, networks, systems, and process, and create security governance mechanism that enables the stakeholders to benchmark their infrastructure. If we are not making any standards or any regulations or policy, then each one will follow their own policy, and it will be really difficult to validate or certify or assess if that particular system is fully secured. So standards are very critical, and NIST has thrown few R&D challenges as part of the cyber security, which has to be analyzed, and a lot of solution has to come for that. Um, so the first one is device level security. So all the systems which are in the power grid now are made assuming there is no need for security. So each device and each component in the power grid has to have device level security, which could be an encryption, which could have device level authentication, and protocol which can handshake, and multiple levels of security, cryptographic and key management, networking issues related security, system level security. All these securities are addressed in different domains. For power grid, particularly the devices, equipment, and also the network is different. And lot of, I mean, when smart grid is thrown up to the public, and multiple generation system, even the consumer can also become a generator. In that point in time, the level of security which is required is really high, and it calls for new R&D and challenges. People can look at providing solution at this for security at these layers. Training, design security awareness and training programs that complies with the organization's local, state, and national policy and regulatory framework that supports overall smart grid security. So once the policy is made, the complete team has to be trained on the standards, policies, and regulations so that they adhere to it, and they also see whether the organization which they belong to, the security is taken care. Cybersecurity strategy is divided. This is the complete flowchart of how a cybersecurity strategy for smart grid is implemented. Take a particular use case and analyze that. See first point, and the second one is risk assessment. So you need first you see the use case, and then take the risk assessment, identify asset, vulnerability, threats, and impacts of that. Then you need to understand from top down as well as bottom up. So multiple components will be involved. So at different levels, how this asset and interfaces, the security threat can happen. So assess that. Then high level, derive, once the assessment is done, derive the high level requirements from there. Give also do the privacy assessment, and that also feed in some of the security requirements which is required. Then from there, from the requirement, derive the security architecture. Then once we know the smart architecture, we need to also see when a requirement is made and regulatory and policies are made, then you need to do the assessment to ensure that security and privacy is met. So smart grid standards assessment has to be made, and we can use the existing standard as the foundation, like the SIP, IEEE, and IEC standards, and combine together all these things together form the conformity assessment. So that is the final strategy which will give the assessment to whether a particular say a power domain or a smart grid is secured or not. So that is very much critical. The assessment is very much important. Now NIST has divided the components of cybersecurity strategy into four. The first one is prevention, and then detection, response, and recovery. So prevention is you need to prevent something which shouldn't happen. Others, if something has happened, you need to have strategy to detect it, and also when after detecting it, there should be strategy to respond and also recover the system from disaster and bring it back. So components of the cyber security strategy is first is prevention, recovery, detection, and then response. The risk assessment model for cyber security. So if you see, you identify threat, identify vulnerability, identify the consequences, and then that gives the risk. Now it might give operational, economic, safety, or environmental risk. Identify which risk it belong to, and once it is identified, then mitigate it. So the last one is the risk evaluation model for cybersecurity. The risk evaluation consists of two main categories. One is risk inspection, and the next is risk attenuation or risk mitigation. And identifying cybersecurity asserts, incorporate testing schemes, determine impact on application and physical layer. So this is how you will inspect the risk. Once the risk is identified, develop security measures and attack resistant smart grid infrastructure, test in real-time platform, propose methods and protocols to mitigate the attacks. So this is how the risk evaluation model of cybersecurity is defined. So in this, we were looking at different components of cyber security. We were looking at cybersecurity strategy. We were looking at the NISTR 7628 guidelines, and also the requirements which is derived out of this smart grid cybersecurity. The next session we will be covering the conceptual model of cybersecurity with some examples. Thank you.